We'll continue the topic chemical equilibrium. In it, we'll discuss physical equilibrium. Equilibrium is also attained in physical processes such as vaporization and condensation. The conversion of liquid into vapor is known as vaporization, while the opposite process, that is conversion of vapor into liquid, is called condensation. When a vessel containing a liquid is tightly closed, the liquid does not evaporate completely. This is because the molecules constituting the vapor cannot go out of the vessel. Most of them condense and return to the liquid. Soon a state is reached when the number of molecules leaving the surface of the liquid becomes equal to the number of molecules returning to the liquid phase. At this equilibrium state, the number of molecules present in vapor state and liquid phase become fixed. Electrolytes and non-electrolytes. Factors affecting the state of equilibrium. It is also known as Le Chatelier's principle. According to Le Chatelier's principle, if a system under equilibrium is subjected to a change in temperature, pressure, or concentration, then the equilibrium shifts itself in such a way so as to undo or neutralize the effect of change of temperature, pressure, or concentration. The various factors that affect the equilibrium are as follows: concentration, the increase in concentration of any of the reactants shifts the equilibrium in forward direction. Similarly, the increase in concentration of any of the products shifts the equilibrium in the backward direction. For example, ferric ion, which is yellow in color, when combines with thiocyanate ion, which is colorless, produces iron thiocyanate, which is red in color. Here, if ferric iron is added in equilibrium mixture, then intensity of red color increases due to formation of iron thiocyanate. The next property is effect of change of temperature. When temperature of the system is changed, the equilibrium shifts in opposite direction in order to neutralize the effect. It is different for exothermic reactions and endothermic reactions. For exothermic reactions, on increasing the temperature in exothermic reaction, equilibrium will get shifted towards left. That is, more of the amount of reactant would be formed. We can see this in the reaction for ammonia. Here in the exothermic reaction, if temperature is increased, then to neutralize the effect of increased temperature, endothermic reaction would occur. Hence, the ammonia would start decomposing and will form nitrogen and hydrogen. For endothermic reactions, on increasing the temperature in endothermic reaction, equilibrium will get shifted towards right. That is, more amount of product would be formed. If we see this in the reaction of ammonia formation, when temperature is increased for endothermic reaction, then to neutralize the effect of when temperature is increased in the endothermic reaction, if we study it in the ammonia formation, then to neutralize the effect of decreased temperature, the reaction would occur in the forward direction, hence energy would be released and would compensate the energy lowered in the previous process. Hence more amount of product would be formed. The effect of temperature on equilibrium position can be demonstrated by studying the following reaction, that is reaction of N2O4 to change into NO2. The conversion of N2O4 to NO2 is endothermic, and the reverse process conversion of NO2 to N2O4 is exothermic. N2O4 is a colorless gas while NO2 is brown colored. When the tube is placed at room temperature, NO2 is brown colored gas. When tube is placed in beaker containing ice, it is observed that color of the gas mixture lightens. It becomes pale brown, indicating that equilibrium has shifted towards right. When the tube is placed in beaker containing ice, it is observed that color of the gas mixture becomes light brown. When the tube is placed in beaker containing ice, it is observed that the color of the gas mixture lightens, indicating that equilibrium has shifted towards left, that is in the exothermic direction. The color of the gas becomes pale brown. On the other hand, when the tube is placed in a beaker containing hot water, the gas mixture becomes dark in color, indicating that the equilibrium has shifted towards right, that is in the endothermic direction.